So this is the last slide, no, I have presented, no, in last week. Okay, so I'm gonna open a new topic today. Still has something to do with, it has a relation with the previous topic, which is for hydrostatic force on a curved surface. So that is the previous topic, and it has a connection with that, no? So for today, I'm going to talk about buoyancy, no? So buoyancy. So this is our next topic. So when we talk about buoyancy, this is the tendency of a body to float or to rise when submerged in a fluid, no? So it is the tendency of a body to float or to rise when submerged in a fluid. So imagine if meron akong object na nakalubog. So may tendency na yung object na yon ay magra-rise, no? Or magpa-float, okay? Due to the presence of the liquid surrounding it, no? So let's say we have this container, an open container. Then we have this object, no? And this object, since there is liquid surrounding it, there's a possibility that it will float. So it will rise now, okay? So that's a possibility until it reaches this part, no? The topmost, no? So it is now floating, right? So it was submerged, and after being submerged, it has now the tendency to rise or to float. So we call that tendency as buoyancy. No? Okay. We have Archimedes principle. It has something to do with buoyancy. Okay. So Archimedes principle states that any body immersed in a fluid is acted upon by an upward force, which we call as buoyant force, no? Equal to the weight of the displaced fluid. I repeat, any body immersed in a fluid, no? So any body, ibig sabihin nun, kahit anong body na nakababad sa isang fluid, let's say water, is acted upon by an upward force. So sabihin nun, basta nakababad, okay, sa body of liquid, no? Nakababad yung object, so magkakaroon siya ng magkakaroon ng force exerted on the object, no? Which is we call upward force or buoyant force. Okay? Kaya siya umakyat eh, no? Yung kaninang example ko, kaya nakita nyo, nag-umangat siya with the presence of buoyant force, no? Na ngayon, paano natin may compute yan? So sabi dito, it is equal to the weight of the displaced fluid, no? Yung bigat ng fluid na na-displace dahil sa presence ng object, no? So to better understand, so before I'll show you the figure. So Archimedes principle can also be called law of hydrostatics, no? Can also be called law of hydrostatics. So consider this figure now, and in this figure we place an object that floats. Okay. Now this object that is floating. Okay. So considering this part. Okay, so as you notice, up to this part, it was wetted, right? So, sabihin niyan, yung part na yan, yung may liquid, no? So, in that case, so this is a three-dimensional figure actually, and sabihin natin it's a siyang cylinder, no? So, it is isa siyang cylinder. And in that case, i-project lang natin pa ilalim. So, itong part na yan na nasa ilalim, ang tawag natin dyan ay displaced fluid. No? Tawag natin dyan ay displaced fluid. Yan. Okay? So, this is displaced fluid. Okay? Kasi nung wala yung object, at yung level ng tubig, or kung tubig man yan, or any liquid. Nung umangat yung object, anong nangyari? Nung yung object nilagay na, umangat yung liquid, right? Aangat. So, dahil umangat, may na-displace na liquid. Diba? Merong na-displace na liquid. Umangat to. Ito yung level. Initially, ganyan siya. Tapos, ito yung original. Dito siya. No? So, sabihin nun, nung umakyat siya, nung umakyat, na-displace yung liquid. At yung na-displace na yon, ito yung nagre-represent imaginary liquid sa loob nitong object. Okay? So, that is the imaginary liquid. So, this is now the displaced liquid. No? Okay? Kasi napunta pa itaas yung liquid. No? So, with that, considering this part, okay, so this is the rise of liquid when the object was placed. No? So, that will be the rise of liquid. Now, considering, so this is the cylinder. So this is the imaginary liquid now. Okay. So this is the imaginary liquid. And considering that imaginary liquid, okay, meron tayo ditong displaced liquid. Okay. Ito yan. Yung displaced liquid. So napunta doon eh. Diba? Ayan. Okay. So ito na siya ngayon. Ito yung dito sa gitna. Okay. Okay. Ito, imagine na merong liquid dyan na nagre-represent dito. Okay? Umangat eh. Ito siya. Okay? So, that is now the displaced liquid or displaced fluid now. So, considering the displaced fluid, so this is the center of gravity. Now, center of gravity. And what are the forces acting at the displaced fluid? So we have the weight of the displaced fluid and the buoyant force. Okay? So those are the forces acting at uh, this imaginary liquid, no? Imaginary body of liquid. So in that case, by Newton's first law of motion, okay, that has something to do with equilibrium. So we sum up forces equals to 0. So going up minus going down, and obtaining that, we have this equation. The buoyant force is equals to the weight of the displaced fluid. Okay, so this is the formula for the buoyant force, which is equal to the weight of the displaced fluid. No? So the weight of the displaced fluid is simply the specific weight of the liquid. Okay, so this is the specific weight of the liquid multiplied by the volume of the displaced fluid. So this is the volume of the displaced fluid. Okay, so considering this buoyant force formula, so take note that the center of buoyancy is the point where the buoyant force Bf acts, that is located at the center of gravity of the displaced fluid. So this is the center of gravity of the displaced fluid. No? So this is the center of buoyancy. No? Okay. So this is where the buoyant force Bf acts. Okay, that is acting at the center of gravity of the displaced fluid. No? So ang tawag doon, center of buoyancy. Yung point na to, center of buoyancy. Kasi ito yung force na kung saan yung buoyant force ay nag-a-act. No? Uh, itong sa point na yan, yung buoyant force ay nag-a-act. Okay? Located at the center of gravity ng displaced liquid na yan. Okay? So, to better understand our topic, let's answer a problem. So, we have a stone weighs 90 newtons in air, and when immersed in water, it weighs 50 newtons. Compute the volume of the stone and its specific gravity. No? So, consider the problem. So, the weight of stone in air is 90 newtons. And when immersed in water, it weighs 50 newtons. So, this is the weight of the stone in air. When immersed in water, it becomes 50 newtons. Okay? Nung nakababad sa tubig, naging 50 newton. Okay? Na-imagine nyo ba pag, let's say, nag-outing kayo for swimming, and pag nasa pool kayo, okay, parang nababawasan yung timbang nyo, no? So, ibig sabihin nun, meron kayong weight in water that is less than your weight in air. No? Mas mababa sa weight nyo sa air. No? So, required are as follows. Compute the volume of the stone. So, the volume of the stone denoted by V, and the specific gravity of such stone, Sg. So, solution to the problem, imagine that it is in air. Okay? So, we imagine that it is in air. So, this is the stone in air, an irregular shaped stone. Okay? Posible ba na makuha natin yung volume? Hindi naman siya perfect sphere. No? Hindi naman siya circular, hindi siya sphere. No? So, kung ganyan yung itsura niya, posible ba makuha natin yung volume? Yes, it's possible. No? Kahit irregular shape yung object, possible na makuha yung volume. So, if I'm not mistaken, this is a lesson in chemistry about water displacement method to find the volume of an irregular shaped object like stone. No? Okay? So, this is a way on how to determine the volume of an irregular shaped object. Okay? So, in this case, we consider the forces acting at the stone. First is the weight of the stone in air. The weight of the stone in air is simply 90 newtons. as stated in the problem. Now, in water, consider that assuming the stone is fully immersed, okay? So we will assume that the stone is fully immersed. It is in water. So when it is fully immersed, okay, 100% of its surface is covered with water. That is the interpretation because it is fully immersed. So it was fully immersed now. Okay? So since it is fully immersed, still it does not float. Bakit kaya di siya nagpa-float? Kasi lamang yung bigat niya sa air, 90 Newton. Meron kang buoyant force. Yung buoyant force na yan, pag yung weight in air, minus ko sa buoyant force, no? Ano nung resulta? Kasi may puwersa siya, original. Meron siyang weight. Okay? Weight niya yon in air. Yun ang original. Nung nakababad siya, may puwersang tumutulak sa kanya paakyat. Ang tawag natin doon ay buoyant force. At ang resulta ay yun ang weight niya sa tubig. No? So that will be the weight of the object in water. Kaya, parang yung object magaan kapag nasa tubig. Kasi madali siyang mabuhat kung nasa tubig kumpara kung walang tubig. Kasi dito, mahirap siyang mabuhat. No? Dito, madaling mabuhat kasi may katulong pa yung puwersa ng tubig. Kaya madali mo siyang mabuhat. Sasabihin, gumaan siya. At yung paggaan niya yon, ang interpretation natin, no, yung weight na yon na bago ay yung weight niya in water. Okay? So that will be the interpretation, no, for that. So this is the buoyant force, and the weight in water is simply the weight in air minus the buoyant force. Okay? So the weight in air minus the buoyant force is the weight in water of the stone. And the buoyant force now is our concern. No? Kasi ang buoyant force has something to do with the volume that we are gonna solve. No? Mayroon siyang kinalaman sa volume na isa-solve. Mayroon siyang kinalaman sa volume na isa-solve natin. No? So, in that case, so inano ko lang to, no? Tinranspose. Kaya nag-arrive dito sa equation, no? So, recall that the buoyant force is the product of the specific weight of the liquid and the volume displaced. So, in this case, the specific weight multiplied by the volume displaced. No? So, sabihin niyan, ang buoyant force na yan ay equal, imagine natin yung stone, nakapaloob dyan ay liquid. No? So, ang tawag ngayon dyan, imaginary liquid. Dahil wala naman talagang liquid sa loob ng stone. Okay? So, imaginary liquid. Paraan lang yan para makuha natin yung buoyant force. Okay? At in that case, so yung imaginary liquid na yan, mayroong specific weight. At meron din volume. Okay? So, yun yon. Pag multiply natin, yun na yung buoyant force. Okay? So, in that case, ito, ayan, originally, ganyan siya. Ngayon, consider natin na ang laman niya ay tubig. Okay? Para sa ating buoyant force. So in that case, this is now there is now volume displaced. No? So and inside it there's specific weight. No? So this is the volume of the stone in air. O ano masasabi natin sa volume of the stone in air and the volume of the stone in water? Uh, Pareho lang ba? Yes, pareho lang. No? Nakababad siya, nagbago ba yung volume? Hindi. Yun pa rin naman ang volume ng stone. No? Fully immersed. So sabihin niya, kung ano yung volume original, yun din yung volume niya nung nakababa dahil fully immersed. Okay? So in that case, we can now conclude that the volume of the stone, okay, when it is in air, is also equal to the volume of the stone which is in water. So this is now the revised equation. So in that case, so we have here the weight in air minus the weight in water. So itong specific weight napunta dyan para sa volume. So the specific weight is considered at 4 degrees Celsius temperature. No? So dahil wala naman sa problem, ano yung temperature ng water? So ganyan lagi yung assumption. At saka kahit yung temperature ng water ay maging 20 degrees Celsius, 50 degrees Celsius, yung yung actual answer hindi nalalayo nun sa approximate answer, no? So yung volume na yan hindi lalayo sa tunay na sagot kahit ano pang temperature yung specify natin. Pero for usually kasi sa board exam, ang kino-consider talaga natin ay 9.81 kilonewton per cubic meter. Okay? So, may times na 9.79 yan. Okay? Pag nag-increase yung temperature, okay, makaka-reach, may possibility mag-reach siya na 9.79. Okay? So, usually, 20 degrees Celsius, if I'm not mistaken, yung water at 20 degrees Celsius has a specific weight of 9.79 kilonewtons per cubic meter. No? So, depende sa problem. Okay, pero pag walang sinabi, no, usually, yung specific weight ay 9.81 kilonewton per cubic meter. So, this is now our solution. Weight in air, 90. Weight in water, 50. Specific weight in terms of Newton per cubic meter, 9810. No? So, considering that, the volume now of the stone is 4.077 times 10 to the negative 3 cubic meter. Okay? So, that is the volume of the stone. Alright. So, I'm done. We now proceed with the specific gravity. Finding the specific gravity. So, yan yung answer natin, no? Okay? So, yung irregular shape na yan, ang naging resulta ay ito. 4.077 times 10 to the negative 3 cubic meter. So, next, specific gravity is our concern. Okay? Specific gravity yung ating concern ngayon. Okay, finding the specific gravity. Ayan. So, for the specific gravity, okay, um, we consider the formula. So tinuro ko na to before that the specific gravity of a substance is the specific weight of the substance over the specific weight of water at 4 degrees Celsius. Minsan nga, pwede rin density of water over density of water at 4 degrees Celsius. Pwede rin yan. No? So, dahil ang ating substance, naturo ko dati substance, pwede naman maging solid object. So, pwede namang stone. Okay? So, over the unit weight of water at 4 degrees Celsius. Okay? So, in this case, the weight in air over the volume. So, the specific weight of the stone is the weight in air over the volume. So, naturo ko naman dati that the specific weight is weight over volume. So, ang weight na to, okay, that is the weight in air. Okay? Hindi weight in water, weight in air. So, then we divide it by the volume of the stone. Okay? And then, will now be the result. So, we have the weight in air, 90 newtons, over the volume of 4.077 times 10 to the negative 3 cubic meter over ito 9810 newtons per cubic meter. So we get an answer of 2.25. So that is our answer. So number 2. So given this problem, we have here a uh, floating system. The system comprises of a log and an iron. No? So there is iron here, there is log, and when we consider it as system. Okay? And considering that the seawater has specific gravity of 1.03. Okay? So yung fresh water at 4 degrees Celsius, 1 yon. Pero pag seawater ang pinag-uusapan, nagbago ng konti yung kanyang specific gravity. No? So, 1.03. So, yung ating log, ito, ang specific gravity niya ay 0.7. Okay? 0.7. So, iron, 7.9. Okay? Sabihin matimbang masyado yung iron. Masasabi na naman natin sa log na magaan siya. Kasi, mas mababa kumpara sa specific gravity ng fresh water. No? So, in that case, so, ang concern natin dito ay makuha yung weight ng iron. No? Para mapanatili yung ganitong posisyon. Ano dapat itong bigat ng iron na irregular shape, no? Irregular shaped iron para mapanatili yung ganitong posisyon na 2 feet yung nakikita sa taas. 2 feet yung hindi nakababad, no? 2 feet sa itaas yung hindi nakababad. So, ang solution dito ay we consider all the vertical forces acting on the system, that is log and iron. No? So tapos ito, walang nabanggit sa problem yung tali. So yung tali, we can neglect the weight. No? We can neglect the weight of this thread. No? So in that case, we have here, we consider the log with the iron, okay, as the system. Yun ang ating system. At yung system na yan will be represented by a dot. will be represented by a particle, no? Ganyan naman talaga yung solution, right? In mechanics of rigid bodies, naaral nyo yan, yung engineering mechanics, no? Or even in physics, natuturo yan, that we can represent the system as a single point, no? Okay? So, in that case, we now consider all the forces acting at the system, no? Acting on the system. So, first is the weight of the log. Another, the weight of iron, no? So, ito yung ating system. Considering the system, may bigat yung log, may bigat yung iron. Another thing to consider is the buoyant force with regard to iron, no? So, this is iron. Merong pwersang paakyat dahil nakababad siya sa tubig, no? So, there is buoyant force. Okay? So, consider natin siya. So, pataas ngayon. And also, log. Okay? The buoyant force of the log. The buoyant force with regard to log. Okay? Ito. So, pataas din. Kasi may pwersang tinutulak pataas siya dahil may tubig. Ganon din dito, may pwersang tinutulak yung iron dahil sa tubig. So, yung pwersa na yon ay buoyant force. Iron and log. Okay? And then, no more forces. Yun lang naman yung mga vertical forces acting on the system. No? So, next, we can consider the sum of all forces vertical equals to 0. So, bakit kaya 0? Recall Newton's first law of motion, no? Which is a law that has something to do with equilibrium. Because the body is at rest, it is considered an equilibrium. The system is at rest. Para mapanatili yung ganitong condition na hindi gumagalaw, natupit ito, sabihin nasa equilibrium, and we can apply Newton's first law. No? So, in that case, summation forces vertical equals to 0. And considering that, we have the buoyant force of the log, upward, buoyant force of iron, upward, kaya positive, no? Weight of the log, kaya negative, downward kasi, weight of iron, downward, so negative. Okay? So, with that, we continue. So, the buoyant force of the log, with regard to log, no? The buoyant force with regard to log is equals to specific weight of seawater, okay, times the volume displaced with regard to log. Okay? So, the volume displaced with regard to log. So, sabihin yan, imagine na yung part na to filled with water. Ito. Okay? Volume displaced yan with regard to log. Hanggang sa part lang na nababasa. No? And then, syempre, ang ating substance ay seawater. Nakapalibot ay seawater. Sa system ay ang nakapalibot ay seawater. So, consider natin ngayon ay seawater. No? So, buoyant force with regard to iron, ito yung iron natin. So, nakapalibot sa kanya ay seawater. Therefore, specific weight of seawater. Then, the volume displaced with regard to iron, ito. So, sabihin niyan, imagine na yung iron ay filled with seawater. Okay? So, and then, weight of the log. Ito na yung weight niya sa air. No? Weight of the log. Okay, weight yan in air. So, the weight of the log ay same formula. Specific weight times volume. No? Yan pa rin naman ang formula whether solid object or liquid substance. Ganyan pa rin naman ang specific weight. Weight over volume. No? So we have specific weight times the volume of the log. Okay? So, specific weight of log, kasi in air siya, di ba? Times the volume of the log. Yun na yun. Then, the weight of iron. Ang weight of iron, yun ang ating concern. Yun ang hinahanap ng problem, di ba? Weight of the iron. Kaya hindi ko na siya binago. Hindi ko na siya in-express na ganito. No? Okay? So, mananatili siyang ganyan. Although, pwede nyo namang gawin. Tapos, compute nyo na lang ulit yung weight ng iron in terms of ganitong form. So, pwede nyo siyang express na ganyang form. Tapos, solve yung volume ng iron. Tapos, solve nyo na ulit solve nyo na yung weight. Kaya lang, ba't di na lang directly na weight na agad? Okay? Ayan, direct na. Excuse me. So we have, dahil ang ating iron ay fully immersed, 100% ay nakababad sa seawater, masasabi natin that the volume displaced with regard to iron is equal to the volume of iron. Okay? So, next, kung ganon, so, ang specific weight ng seawater, naturo ko na dati yan. Okay? Specific weight of a substance is equal to specific weight, or should I say, specific gravity, okay, times specific weight of water at 4 degrees Celsius. Diba? Naturo ko na dati yan. Okay? The specific weight of the substance is equals to the specific gravity of the substance multiplied by the unit weight of water at 4 degrees Celsius. So, kung ganon, so specific weight ng seawater ay equal dito. Specific gravity of seawater multiplied by the specific weight of fresh water at 4 degrees Celsius. Okay? Multiplied by the volume of the log. The volume displaced with regard to log. Okay? So, and then, ganito pa rin. Okay? Specific gravity seawater, specific weight fresh water at 4 degrees Celsius. And then, ito naman, ito siya. Ang specific weight ng log, okay, ay specific gravity ng log, okay, multiplied by the specific weight of fresh water at 4 degrees Celsius. Okay? And then, ayun, mananatili lang siya. Weight of iron. Okay? Next, we have specific gravity of seawater. Okay na yan. Umulit na lang yan. Ito naman, ito yung nag-iba. Volume of iron, weight over specific weight. Kasi ang specific weight is weight over volume. So therefore, we're interested in finding the volume that is weight over specific weight. Okay? Kaya weight over the specific weight. And then, hindi naman nagbago to. Okay, yun. So we can proceed. Alright, we have here, we can able to, ito weight of iron, right? So, saan yung itong part na to, may weight of iron. Tsaka ito, may weight of iron. So, sabihin niyan, minus 1. Minus 1 weight of iron. No? So, itong part na yan, specific gravity, seawater, ito yun. Unit weight of water over unit weight of iron, minus 1. Kasi minus 1 doon. Pinactor out ko. Alam niyo naman yun sa algebra, right? So, factoring. So, that is fundamental in algebra. Okay. So, and then, specific gravity, we can transpose ito to the right side. No? Ganun din dito dito, to the right side. Okay? So, in that case, ito yung magiging resulta. Specific gravity log, okay, ito, tsaka yun, minus ito. Nakuha yun, no? And then, we can simplify. Specific gravity, unit weight of iron is equal to the specific gravity of iron multiplied by specific weight of water at 4 degrees Celsius. Okay? That is the unit weight of iron. And then, dito naman is pinactor out ito. So, meron tayo nito ngayon na factor out. So, specific gravity of log, volume of log, specific gravity of seawater, volume displaced with regard to log. No? So, we have here ito, nawala na yon, cancel. Okay. Kaya naging ganito yung expression natin. And then, yun lang, na-maintain. And then, we can able to solve for the weight of the iron. So, specific weight of water, ito, maintain. Then, ito, ilalagay natin sa ilalim. No? And then, considering itong equation, so, take note, no? Yung upper part, so meron niyang area, yung upper part. So, the area is denoted by B. So, twice, kung recall natin, in geometry, this is a cylinder, right? This is a cylindrical log, as you can see, no? Kasi meron siyang 1 foot diameter, tapos meron siyang height na 18 plus 2. So, sabihin niyan 20 feet. Meron siyang height na 20 feet. So, ito yung area of the base. Ito yung ating length or the height of the cylinder. So, ang volume niyan ay BL. Area of the base multiplied by the height or multiplied by the length. So, and then we consider the diameter. Okay? The diameter of the cylinder. So, pagkuha ng area of the base, pi over 4 d squared. Kasi circular siya. Area of a circle. And then, we have now this equation. So, weight of the iron, specific weight of iron, 62.4. As a specific weight of water at 4 degrees Celsius, 62.4 pound per cubic foot. Specific gravity of log, 0.7. Volume of log, itong log na yan, pi over 4 d squared. Pi over 4 d squared. So, 1 squared. So, area pa lang yan. Ito, area. Yan ang B. Tapos, ito yung L. BL para sa volume of log. Okay? So, ang kanyang height or length ay 20 feet. 2 plus 18. 20 feet. No? BL. So, ito yung volume of log. Okay? So, then, specific gravity of seawater, 1.03. And then, volume, volume displaced with respect to log, no? So, in this case, yung volume displaced with respect to log, so, consider natin yung nababasa lang. Okay? So, in that case, ang area ng base ay kapareho ng area na nasa taas. B pa rin yan. So, pi over 4d squared. No? And then, pi over 4 1 squared ngayon. Ang kanyang length, ay 18 feet. Yung nababasa. Okay? So, in that case, pi over 4, 1 squared multiplied by 18. So, BL ulit yan. No? So, BL na bago, BL prime, sabihin natin, 18 feet. Itong BL original. Okay. And then, so, ang anong unit nung nasa loob? Analyze natin. Ito ay feet, tapos naka-square. 18 plus 2 ay feet, minus ito walang unit, specific gravity, walang unit yan. Ito ay feet squared, ito ay feet. So, feet cube ngayon, feet squared, feet is feet cube, minus feet cube. So, ibig sabihin yung feet cube yung unit. Okay? Pinactor out na natin. So, and then, specific gravity of seawater, 1.03, iron, 7.9, okay. Ito, minus 1. So, we get an answer of 255.9 pounds. Okay? So, that will be the weight of iron, no? 255.9 pounds. Okay? So, number 3. So, the block shown in the figure weighs 35,000 pounds. Find the value of H. And let's analyze. No? So, we have here an object na kung saan, imagine ganito yan. Halimbawa, meron kang water. Ito, water. Tapos, meron ka ditong oil. Tapos, merong nakababad na object dyan. Okay? Tangke. Ito yung tangke, yung nasa labas. Tapos, may nakababad na black. So, sabihin, ano siya, dalawa yung consider natin. Isa para sa oil, isa para sa water. Ayan. Okay? Kanina, isang liquid lang ang kinonsider natin. Dito, dalawang liquid. Water and oil. No? So, in that case, so given, ito yung ating block. So, ito yung dimension niya pala, 9 feet. Yung haba dito, 12 feet by 12 feet. Ibig sabihin, may third dimension yan, na 12 feet by 12 feet. No? May third dimension. Okay? So, ang hinahanap dito is, ano yung age na to? Okay? No, nagpa-float kasi, nagpa-float yung block. Ano yung height na to sa part ng water? Okay? So, in this case, let's consider the the centroid of this area, wherein the centroid of this area is represented by the center of gravity. No? Kasi actually, meron yung third dimension, gaya ng sabi ko. So, consider natin ngayon yung center of gravity niya. No? So, the weight of is 35,000 pounds. Yun ang given sa problem. And required natin ay height. So, kung ganon, kung ang required natin ay height, okay. So, solution to the problem, considering all the vertical forces acting on the block. So, consider lahat natin ng forces acting on the block. Okay, una-una, itong part na to ay nababasa. Diba? Or should I say, dahil nakababad sa tubig, sabihin natin ito ay imaginary. Nasa loob dito. No? Nasa loob ng block. So, sabihin niyan, outer, nababasa siya. Outer. Sa outer nababasa ng water. Ganito rin dito. Sa outer, nababasa siya ng oil. Okay? Oil. So, with that, consider natin yung block as a single point. No? Ano lahat ng forces acting on the block? First, we have the weight of the block. No? The weight of the block. Itong block na yan. Okay? Okay, so consider natin yung weight niya. Tapos, meron kang buoyant force due to water. No? There's buoyant force due to water. No? Ito. May pwersa na ine-exert ang water para mag-float yung ating object. Kaya merong buoyant force due to water. Meron ngayong buoyant force din due to oil. May pwersa na ine-exert yung oil para lumutang yung ating object. So, meron kang buoyant force due to oil. So, yun ang tatlong pwersa na vertical na nag-a-act sa ating block. No? At with that, block is in equilibrium condition. Okay? So, nasa equilibrium siya. So, nagpa-float eh. Sabihin na at rest. Okay? So, it is in equilibrium. And we can apply Newton's first law of motion. And in applying Newton's first law of motion, we can equate all the forces acting at the block equal to 0. No? So, we have here upward, upward, downward. Kaya buoyant force of oil plus buoyant force of water. Buoyant force due to oil plus buoyant force due to water minus the weight of the block equals to 0. Okay? So, the buoyant force due to oil is simply specific weight of oil times the volume displaced. Okay? The volume displaced due to oil, or should I say with regard to oil, plus unit weight of water, the volume displaced with regard to water, okay, minus the weight of the block equals to 0. So, the unit weight of oil, specific gravity of oil, times specific weight of water, fresh water at 4 degrees Celsius, times the volume displaced with respect to oil, plus specific weight of water at 4 degrees Celsius. So, kasi dito, hindi sinabi anong temperature ng water. So, assuming 4 degrees Celsius. So, the volume displaced with respect to water is Ito siya. So, di na bago. Minus the weight equals 0. So, transpose natin yung weight to the right side of the equation. So, we can factor out specific weight of water at 4 degrees Celsius. So, what is left is specific gravity of oil, volume displaced with respect to oil, plus volume displaced with respect to water. Okay? Equals to the weight. So, ito yung ating, consider natin sa oil. Okay? So, imagine, di ba, 12 feet by 12 feet. So, ito yung oil. So, imaginary oil, in short. This is filled with the imaginary oil. No? Yung ating block. Para sa pag-compute ng buoyant force. Or para sa pagkuha ng volume pala. No? Para sa pag-compute ng volume with respect to oil. So, with that, this is now the imaginary oil inside the block. Ito siya. So, ang volume niyan ay area of the base, BO, okay, multiply by L, the length. And alam natin, ito ay 3 feet. Ito. So, 3 feet. Kaya 3 feet yan. Ito ay 12 feet. Kasi 12 feet by 12 feet. Isabihin yung third dimension dito ay 12 feet. Okay? Or should I say, 12 feet nga. Tsaka itong dimension na to, na pangalawa, ay 12 feet. Pareho din dito, no? Pareho din doon. Okay. Okay? And then, so 12 feet, ayun, third dimension. So, the volume displaced with respect to oil is, alam nyo naman to, di ba? Rectangular prism. Okay, this is a lesson in geometry. Okay? I hope siguro naturo naman sa inyo yung volume ng pagkuha ng rectangular prism. Or kung hindi man, simple lang naman yung formula, BL. So, area of the base, BO, multiplied by the length. No, ito yun. Area times mo yung length na yun. So, ang area niyan ay length times width, 3, tapos 2 ay 12. So, 3 times 12 times length is 12. Ito yung length na 12 feet. Okay? Ayan. So, magkakaroon ka ng answer na 432 cubic feet. Alright? So, ang concern natin ay height, yung age. Okay? Hanapin muna natin yung volume due to water. No? Yung volume displaced with respect to water. So, with that, we can now consider this volume. Ito. So, imagine na sa loob ng block, there is imaginary water. Ito, imaginary water yan. So, ganun pa rin. BWL, height. Ito yung nahanap natin, yung concern natin, yung height na yan. Okay? Which is equal to this, na itong height na yan. Kasi ito yun, di ba? Yung height. So, then this is 12 feet, no? So, yung pagkuha ng volume with respect to water ay weight over specific weight of water at 4 degrees Celsius minus specific gravity of oil times the volume displaced with respect to oil. So, paano naging ganon? Okay, nanggaling lang yan dito. Ito yung original nung previous slide. Na-derive natin to. Tapos, ginawa natin yung volume of water. Volume displaced with respect to water. So, nag-algebra lang ako, kaya naging ganito yung equation. Weight over specific weight, ito. Tapos, i-transpose sa kabila yon. Ito yon, yung SGOVO. So, makukuha mo yung volume displaced with respect to water. Alam niyo naman mag-algebra, right? Okay. So, we can proceed. So, ang volume displaced with respect to water, no? Pagkuha niyan, BW. Ito yung BW, ito yung L, yung 12. So, BW, ito ay age. Therefore, ito rin ay age. Ito ay 12 feet, ito rin ay 12 feet. Kaya, length times width, 12 times age. So, kaya 12 age. Then, length. Ito yung length na 12 feet. Okay? So, then we have weight, 35,000. As stated sa problem. Pounds yon. Tapos, specific weight, 62.4. Okay? Pound per cubic feet. Pounds per cubic feet. Then, SGO, given sa problem, no? Na 0.8. Ito. Volume, displaced with respect to oil. Nakuha sa previous slide, yung sagot, 432 cubic feet. So, masasolve na natin yung H. So, 35,000. Pinakita ko lang yung unit nila. Over 62.4 pound per cubic foot minus 0.8 for 32 cubic feet all over 12 times 12 square feet. Kasi ito ay 12 feet, 12 feet, so square feet. Okay. So makuha natin, pounds, cancel, cubic feet. Cubic feet. So ito, tataas yan. So magiging unit niyan ay, kung tataas yan, cubic feet, tapos minus unit na cubic feet. Tapos meron ka dyan na square feet, no? So, ang resulta ay cubic feet over square feet, feet na lang. Kaya ang unit niya na magiging answer natin ng H ay feet, no? So, 1.495 feet. Okay? So, that is our answer. H equals 1.495 feet. So, and that ends my discussion. So, that's all. Thank you.